with Lewis structures, we need to find multiple bonds sometimes, and there are easy ways and more difficult ways to do that. So I have a trick that is probably not found in your textbook. So I wanted to show something first, just that of a way you could find it. Bear with me because I have to draw all this. But if I have C2H4, I want to do symmetry. So I'm thinking, okay, for every C, I'm probably going to have 2 H's, right? So there are my 2 C's with my symmetrical H's. If I do the dots, and here I have 1 for each of my H's, and I have 4 for my carbons. And what we start seeing is that these pair up. So that pairs up, that pairs up, that pairs up, and so on and so forth. And then you see that you have these extra ones, and you can't stop here. The reason why is that this is 2 times 4, so there's 8 valence electrons from this, and 4 is from the periodic table, and then this is just 4 times 1, so this is another 4. So I should have 12 valence electrons. Okay, well, if I count this up, I have 2, 4, 6, 8, 10, 11, 12. Good. But remember, the second check is that I need octets. So if I look at my H's, I can't have octets on H's, so I have just lines on my H's. That's good. But on my carbon, I have 2, 4, 6, 7. 2, 4, 6, 7. So that's not good enough. So if you don't have enough electrons on each, then you need to share more. So what you can do is say, oh, hey, these two could come here and here, and then I can cause a double bond. Well, what does that do to my checking? Well, I have 2, 4, 6, 8, 10, 12. I still have 12. But do I have octets on my C's now? 2, 4, 6, 8, 2, 4, 6, 8. Awesome. So now I'm done. Well, maybe that works out, but when I get to something like this, it doesn't. So SO3, so I have 6 and 18. I already figured that out. 1 times 6 and then 6 times 18 again from the periodic table. So I draw this out, and I'm going to try to make this very complicated to show you that this is hard. So I have 6 here. I have 6 here. 6 there and 6 here. So if you start sharing, you go, okay, there's a bond, there's a bond, and there's a bond. And you're done. Problem is 2, 4, 6, 7. Shoot 2, 4, 6, 8, 2, 4, 6, 7, 2, 4, 6, 7. Okay, that's not going to work. Well, sharing doesn't need to be equal. You don't have to share equally. You could go to someone's house and not share your toys, but if they have toys, then you could share all of their toys. What I mean by that is, what if I rearrange this? Bring this here, let's say. And what if oxygen decides to share all of its electrons? That's still not enough. It's 2, 4, 6. So what if instead sulfur said, okay, fine. Oxygen, you're not sharing. I will share more. So sulfur still has 6, right? 2, 4, 6, 8, 6, I mean. So now if I do that, oxygen still has its 6, but it's 2, 4, 6, 8. Same thing here. What if I balance out that? And that's great. And then I rearrange this as well. And move these down here again. Sorry, bear with me here. Now look at the oxygens. 2, 4, 6, 8. Great. 2, 4, 6, 8. 2, 4, 6, 8. Do I have 24? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. But what's the problem? 2, 4, 6. I only have 6. That's the problem. So when you don't have enough, you need to share more. So what happens is that oxygen right here needs to go, okay, fine, I'll share some as well. So now it's 2, 4, 6, 8 on the oxygen, 2, 4, 6, 8 on the sulfur, and I still have 24. So when I rewrite this then, this is how it would look. And I'm doing this with a mouse, so sorry. Here's my double bond. Oops. No double bond there. My fault. And then I need to give all the electrons. But why does it have to be on this bond? Why isn't it on this bond? Or why isn't it double bond on that bond? And that is what we call a resonance structure. And resonance structures are structures with more than one possible structure, usually moving extra bonds around. So if I look at this one, how many different resonance structures could I have? Well, it all depends on where I have the double bond. So I could have it here, I could have it here, or I could have it here. Well, I need to show all those. So this is how I would do it. And I have to have these arrows. I can have the double bond here, here, or here. So it cycles through. In fact, each of these bonds is kind of considered a 1 1/3 single bond or a 1 1/3 bond because it doesn't have a single bond. It doesn't have a double bond. It always, at any moment, has 1 1/3 bond in a way. So we got to show them all. Okay, well, that's not easy. That was complicated. That's complicated. So I haven't come up with this method, but I definitely use it a lot. It's called the TV method. And it's about finding extra bonds. So there's 2 steps. It's not in your book from what I know. So I already kind of have this all made out here, but I'll go slow. Here's the first question. What if it had all single bonds? So you give everything an octet except H. So here we go. I'm giving it all an octet. So 2, 4, 6, 8, 2, 4, 6, 8. I don't give each thing 8. I give it 8 with sharing. I still need to share. So you draw, I call it the skeleton. You draw a single bond, and then you just give it the skeleton outline with all single bonds. That is called T for total electrons. I have 14. 2, 4, 6, 8, 10, 12, 14. So that's T. Then the second question I have to ask is, how many electrons should I have? So valence electrons. Well, that links to the formula. 6 valence electrons. And I have 2 oxygens. So that's a total of 12. So V stands for valence. So T minus V, TV. T minus V in this case equals 2. What's the big deal about that? Well, for every 2 electron difference, an extra bond is needed. Basically, what I'm saying is that this picture right here is saying I have 14, but I'm only supposed to have 12. So my picture has 2 too many. So it needs to share more. Again, I wrote another way. You draw the skeleton, single bonds only. Then add extra bonds to existing bonds. So I have 2 too many. Well, 1 line equals 2 electrons. So what I'm going to do then is I draw the bond, and then I have to add an extra bond. So this 2 is right there. And then I finish the octets. So if I go 2, 4, 6, 8, 2, 4, 6, 8. So that equals a total of 12 because I have 2, 4, 6, 8, 10, 12. So let's look at a couple other examples. Here we go. CO. We'll start small and we'll get a little bit bigger. So it's supposed to have 4 from a C and 6 from an O. So that's going to make V as 10. Okay, that's how many it should have. Well, I don't have a drawing here. Okay, I'll draw it myself. So what I would do is I draw the skeleton, give everything an octet. So this one's similar to the one above. Again, 2, 4, 6, 8, 2, 4, 6, 8. And that equals 14. So that's a difference of 4. So what does 4 mean? Well, for every 2 difference, you need 1 extra bond. So I need 2 extra bonds. So I draw the skeleton, meaning just it has to bond once. Everything has to bond once. And then I'm going to add 2 extra bonds. I'm not calling them multiple bonds. I'm calling them extra because they go on the existing bonds. And then I complete the octet. So I have 2, 4, 6, 8, 2, 4, 6, 8. Does it have a total of 10? Well, 2, 4, 6, 8, 10. So remember from the last lesson, if you have the number of octets and the number of valence electrons, then you have to be right. Let's look at one more, N2O. And if I gave you the hint that N is the central atom, oh, shoot, I already drew it all out. It would look like this. Well, if I, shoot, I'll go over here. If I drew it like this, here's my skeleton, okay? So I give everything an octet. So 2, 4, 6, 8, 2, 4, 6. Come on. 8. 2, 4, 6, 8. That's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That's 20. That's how many I have for t. How many should I have? Well, 2 times 5 with n. Sorry, I had to pause that for a second. 2 times 5 plus 6, that's 16. So that's a difference of 4. So that means 2 extra bonds. So this is why I could have a choice. I'll do it in a different color. I could put double bonds here, or I could do 3 on 1. So when you're all said and done, this is what it looks like. I could have 2 here. I could have 2 here. I could have 2 here. So that's why this is a resonant structure, because I have to have all the different possibilities. So when you're going through the worksheet on the back, that's how you're going to find T and V. And again, T is the total if you had all single bonds, and V is how many you should have. If you have any questions, write me emails, send me specific problems, and we can try to work it out. All right, good luck.